Hi, I'm Catherine. I'm a first-year PhD at the University of Hull, and I'm going to talk to you quickly about my project. The modern marine benthos is characterised by burrowing organisms, so things like hedisti and other sort of polychaetes and nematode worms, that sort of thing. These animals introduce oxygen into the sediment and through their burrowing behaviour and feeding mechanisms. However, for most of Earth's history, the seafloor looked like this, covered by thick microbial communities. These microbial communities, or mat grounds, blanketed the sea floor, creating a physical barrier, which, when these develop in modern communities, they stop animals from accessing the sediment and create an anoxic and often very carbon and sulfur-rich conditions in the sediment. Such conditions are often toxic to modern animals. However, despite this apparent toxicity to animals, we see a rapid decline of these microbial mat communities throughout the Paleozoic, to the point where microbial mat communities are all but absent from the Mesozoic and onwards. At the same time, we see a rapid increase in the abundance and diversity of burrowing animals like this. This raises the question as to how early burrowing animals established themselves in conditions that were fundamentally hostile to them. One way we may examine this is by looking at the behaviour of modern burrowing animals in microbial sediments. However, an issue with this is what exactly a Precambrian microbial sediment was actually like, as there is some evidence suggesting that the composition of a microbial mat can impact on its resistance to an animal trying to burrow into it, and also its resistance to erosion. So to this end, we performed some initial experiments. Sorry about the pretty grotty pictures there. We performed some initial experiments looking at how we might induce different biofilm growths in the labs. So we initially looked at the removal of diatoms, which weren't around until roughly the Mesozoic, and other photosynthesizing organisms from a biofilm. This was done by growing microbial mats in semi-defornated sediments, so sediments that had been filtered to remove as much of the animals as we possibly could, under illuminated and dark conditions. In the illuminated sediments, life continued on relatively as normal, and we had a greenish biofilm developing. The few animals that were present remained buried in the sediments and weren't visible. However, in our anoxic, I'm giving away the sentence now. In our non-photosynthesizing sediments, we had rapid anoxia developing, with these quite nasty black sediments developing within a couple of weeks on the sediment surface. And any animals present, we saw a max exodus of animals from the sediment to the surface. The biofilm developed had more of a yellowish hue. We later looked at the biofilm component under the microscopes, and in our illuminated community, we had extensive diatoms and other things growing as expected. However, in our non-illuminated community, there was virtually nothing. So in future experiments, we're hoping to better characterize what exactly we were growing in the non-illuminated community. It's most likely to be bacterial or fungal in nature. So we're hoping to perform some DNA analysis experiments on these dark biofilms to try and figure out what we grow. Once that's achieved, we're hoping to start introducing different types of burrowing organisms, such as these ragworms here and corophiums here, to these different types of biofilms, and seeing what types of burrowing organisms are better able to survive and colonize these pretty microbial dominated sediments. This might allow us to figure out what animals might have led the charge, so to speak, into colonizing this Precambrian mat grounds.